Take a moment to read the question. So omega is a complex number such that 2 omega plus 1 is equal to z, where z is equal to the square root of minus 3. If this determinant is equal to 3k, then we have to find out the value for k. How do we do this question? Well, the first step is to write down z as the square root of 3 times I, where I is of course the imaginary unit and I square is equal to minus 1. Now 2 omega plus 1 is equal to the square root of 3i, which means we can solve for omega and we find that this is what we get. Now this one is nothing but the cube root of unity, and we are familiar with the properties of the cube root of unity. We know that omega cubed is equal to 1, and also 1 plus omega squared is equal to 0. That means omega to the power 7 can be written down like this. Now omega to the power 6 would be equal to 1, so this now is equal to omega. Similarly, minus omega squared minus 1 would be equal to omega. So with this we can write down our determinant in this form. This determinant can be replaced with a simpler determinant like this. Now operating on the columns, we can write it down in this form. So over here we have done the column operation, column 1 transformed into column 1 plus column 2 plus column 3. In this determinant, we can see that 1 plus omega squared is equal to 0. So we can write it down in this form. All we have to do is to expand this determinant along the first column. So on doing so, we find that this is what we get. Now omega to the power 4 is same as omega, so we can write it down like this. Now we know the properties of omega. 1 plus omega squared is equal to 0, which means we can write it down like this, and that's equal to this expression. So we can take out the negative sign and write it as minus 3 times 1 plus 2 omega. But then this is just minus 3 times z. Therefore k is equal to minus z. So the correct answer is option 4.